All right, we're back. So now, what if we want to find the domain and the range of a quadratic function? Well, let's think about this. So what does a parabola look like? Well, if we have a minimum, it looks like that. If we have a maximum, it looks like that, okay? Now, what is the domain? Well, that's all of our x values, right? So it's going from left to right. Now, these aren't drawn very well because, it'd really come up and it would kind of be more like that or like that. And then you can see it a little bit better here. I have more like U's here. So maybe those U's are not the key thing to have there. Maybe we should do it, with our more spread out values here. And so, we're going, each direction, positive and negative. And as this goes down, it's going out basically as all x's. And so that's why the domain, which is the x's, x values, of any quadratic function is going to be all real numbers because we can go either direction forever and ever because this is just going to keep going down and down and down. And when it does, it's also going left and left and left, okay? But then we have something different for the range, okay? And now our ranges, if we have something that's, got a max, our range is going to be basically everything from that value here down to negative infinity. Whereas this one is going to have some min value, whatever it is, and it's going to go all the way up to positive infinity. So let's look at what those ranges look like in terms of our functions and how we can represent it. Okay, so the domains, again, is going to be all real numbers. But if we have a general form, let's start with that one. So general form, we have ax squared plus bx plus c. And we can find our range in the following way. So if a is greater than 0, what we're going to do is your f of x is going to be greater than or equal to f of negative b over 2a, basically your f of h, okay? And so, or this whole thing is basically your k. So if we want to think about this, that whole thing is k. So f of x is going to be greater than or equal to k. But, this piece in here is our h. And so because of that, we have to find what h is, which is minus b over 2 times a. And then we plug that whole thing into the function and solve for k. And then it's going to be a bracket and then f of the minus b over 2a, or whatever your k is. So that's really what this is going to be, comma, infinity, okay? And so if we think about that, that means it's opening up, it's going to positive infinity. And so we have to basically figure out where this point is on the x-axis. We know it's going to be somewhere and we just have to find it. Now, if it's less than 0, guess what? Now we have a max, and so it's going to be some value again. Now it's going to be f of x is less than or equal to that k value. And so it's going to go from negative infinity, because we're going to go all the way down, up to whatever that k value is, and then in bracket, okay? Now that's if we have this form. Now if we have it in the standard form, it's much easier because you know what? We don't have to do any work. We don't have to plug and figure out h. Then we don't have to figure out what f of h is. We just say, okay, well, we've got the function written out in the standard form. We know what it is, so we can just say k is going to be great. It's going to go from k with the bracket to positive infinity if we have a greater than 0, and if a is less than 0, we go from negative infinity up to k and include that number, and that's when we have the maximum. So again, we're finding the same things here. It's the k here and the k here, but we have to do a little bit more work when we have that general form. Okay, so let's go over here and check out some problems. Now, what do we say about the domain? All real numbers. So, we're pretty good to go here. So we can just say all real numbers. And guess what? It's going to be all real numbers here. So we did that. We didn't even have to think about anything because we know we have that quadratic function, and so it has to be all real numbers. Now we have to think about, what do we do now? Well, this one, remember, it's just we go for a greater than 0, we have bracket k comma infinity. Well, k is there, so we just have bracket 8 over 11 comma positive infinity parenthesis. Okay, and again, we just had to use that k value. Now this one doesn't have a k value. We have to first find h. So h is equal to a minus b, so a minus 4 over 2 times a, which is 2, which is equal to a 4 over 4, which is equal to 1. Okay. Now, what is k? Well, k, we just plug in 1 into our function because this is just equal to f of basically your h. And so we're going to plug in the h is 1, so then we want f of 1, and that's going to be 2 times 1 squared, and then minus 4 times 1, and plus 2. So that's 2 plus 2 is 4, minus 4, so that looks to be 0. Okay, so our vertex is 1 comma 0. But what we really needed is we needed to know what our range was. That's really what we're after. I mean, I wrote the vertex down, but we didn't need that. So a greater than 0, so it's going to go up, and so we're going to have from our k, which we found to be 0, up to positive infinity, because it's going to go from this point on up. All right, let's see if we have some more of those. We don't, but what we're going to do next is we're going to determine the minimum and maximum values of a function. Well, do we think we can do that? I mean, think about this one. You know, this is going to be a minimum. What if we had that? Well, that's going to be the max, and we know the vertex is h comma k, or in this case, you know, h comma k, h comma k, and so it should be our k values. Okay, so we have our hk, and if a is greater than 0, we have a minimum. Well, that fits what we see here, and the value is k at x equals h, which is kind of what we thought. We thought that that's going to be our minimum value because that's where it is on our axis. So you know, if we had the at 1 0, well, maybe that's 1 0. We can hope that's 1 0, but our value is at 0. Okay, now this one, maybe our value was a little higher or whatever, but that's how we do it. And then if we have a less than 0, so we have the maximum value, that's going to be k again at the x equals h. Okay, so that's how we're going to use our vertex to find the minimum and maximum values. Then we're going to determine the x and y intercepts. And from the general formula, if it's factorable, now that's the big key, we evaluate f of 0 to find the y-intercepts, okay? So then we have to solve the quadratic function f of x equals 0 to find the x-intercepts factor, and then use our zero product rule, okay? So, you know, what we'll do is we'll factor it into two things, set each factor equal to 0, and then we'll have, you know, x equals and x equals, or whatever our variable is. And so that's going to be our intercepts, okay? Now that's only when it's factorable. If it's not factorable, we're going to rewrite it in standard form, okay? So we're going to substitute a and b into h equals the negative b over 2a. We're going to substitute x equals h into the general form, solve for k, you know, no surprise there. And then we're going to rewrite in standard form using a, h, and k. So a comes from the original problem, then h and k we just found. And so then solve for when the output of that function will be 0 to find the x-intercept. And so the quadratic equation may be used to find x-intercepts when all else fails. So if we can't do it this way, we can't do it this way, you know, that's probably our next best guess, is to do it the final way. And, you know, each person's going to be their own way to figure this, because, you know, some people have trouble factoring. Maybe part B here, this is going to be the easiest way, rewrite it in standard form. Or some people say, hey, I know the quadratic equation, I can plug in here really quick and I get my answers that way, and you're going to have a plus and a minus. Okay, so again, all depends on what form you get. So again, so this one, you know, we had originally some kind of a f of x equals ax squared plus bx plus c, and we factored that into two things. This one, we started with our f of x equals ax squared plus bx plus c, and then we went to some new function, let's call it g of x, into a times x minus h squared plus k. And so then we got to that, and then we solved the output for when the function will be 0, and we could figure out the x-intercept from there. Or we just plugged a, b, and c into our function here, and we get that. All right, so excuse me. What we want to do is we want to find the min, the max, the axis of symmetry, which again, remember, that's just going to be your h, x equals h, and then we need to find the domain and range and the x and y intercept. So we got quite a bit of things here to do. All right, so what do we want to do first? We could do, I guess the domain is going to be pretty easy. Well, that's just going to be all real numbers, okay? Now our range, okay, this is positive, so it's going to open up. So we know it's going to be something bracket, comma, infinity. And so we just need to find what our k is, okay? So how do we find k? Well, first we find h. So h is equal to a minus 10 over 2 times 2. So that's going to be a minus 10 over 4. So it's going to be a minus 5 halves. And so that's going to be our h. And so k, remember, is we just plug in h into our function. So that's going to be 2 times negative 5 halves squared plus 10 times 5 halves, that's negative, and then plus 12. And if we plug that into our calculator, which I got to do right now, so we have 2 times negative 5 divided by 2 squared, and then plus 10 times negative 5 divided by 2 plus 12, we get a negative 1/2. All right, so that's equal to a negative 1/2. That's our k, that goes in here. And so that's going to be our range. So we've got the domain and range already done. So we're good to go there. So we also have a vertex because we says we need the, didn't it say vertex? Nope, didn't say a vertex, but we've got our vertex now, and that's going to be our h comma k. So negative 5 halves, negative 1/2. And from the vertex, we can get our axis of symmetry because that's going to be x equals what? Negative 5 halves. Okay, so we kind of have it, and it's just because we got the vertex from there. All right. So what's the next thing we need to do? We have axis of symmetry taken care of. We got the domain and range. We got min and max and x and y intercepts. So, okay, that works. So what do we have here? We have, this is going to be opening down, so we have a minimum. And so what is our minimum? Our minimum is equal to our k value, negative 1/2. And that's at x equals negative 5 halves, because we kind of have to label as it's the minimum of negative 1/2 at the x value, and we see that over here. So we get the minimum value is k at x equals h, and so we kind of have to write that whole thing out to show where it's at. All right. Then we can get the y-intercept, and that is basically when we say f of 0, and we plug in 0 for everything, for x, okay? And the y-intercept is going to be, well, that's 0, what's left? 12. Okay, so that gives us the y-intercept is equal to 0, 12. That was not too bad. All right, so now what do we want to do? Well, let's look at our function here. And remember, if we want to find the x-intercept, we have to set this equal to 0. So 0 equals 2x squared plus 10x plus 12. Okay. Now, can we factor this? Well, I see we have a common factor here. There's a 2 I could pull out of everything. So if I do that, maybe it'll make it easier to factor. Now I can divide then both sides by 2, and so 0 equals x squared plus 5x plus 6, which then, can I factor that? Well, that's going to be x plus 3, x plus 2, it looks like. And so if I FOIL it out, it's x squared plus 3x plus 2x, that's 5x plus 6. And so now I set x plus 3 equal to 0 and x plus 2 equal to 0. So x equals negative 3 and x equals negative 2. And so our x-intercepts r, and we have 0, x comes first here. Don't know what I'm doing. Actually, I do, but I just don't know. My pen doesn't know what I'm doing. Negative 3 comma 0 and negative 2 comma 0. Okay, those then are my two x-intercepts. So I have that. I've got my y-intercept. I've got my minimum value. I've got the axis of symmetry. Okay, so I've got my domain and range up here. So, and then I've got the min, the axis of symmetry circled, the domain and range circled, and my x and y intercept. So we've got everything that it asked for in the problem now. So again, we just had to go through all the different pieces to figure out what it was. So it takes a lot of work, but you know, none of it's hard. It just takes a little bit of time to get there. All right, what about this one? So again, we have some function, minus 4t squared plus 6t minus 1. We see that a is less than 0, so we know we're going to have a max. So that's going to be a key. We have a max. But before we do that, let's go ahead and write our domain and range, because that's going to be probably the first thing we can find. Domain is all real numbers. And our range, because it's a max, it's going to go up to something and it's going to go down to negative infinity. Okay. Now, what is that? Well, we have to figure out what h is first. So h is going to be a minus b, which is a minus 6, over 2 times a, which is a negative 4. So that's going to be a negative 6 over a negative 8. Okay. Well, that's going to become a positive 3/4. So that's my h. So, well, what do we have from that? Well, we have axis of symmetry is equal to x equals 3/4. So we have one of our things done. So let's go ahead and circle it. Now we need k. Well, k just plugs in h into this equation. So we have a negative 4 times 3/4 squared plus 6 times 3/4 minus 1. Now, if we plug all that in, let's see what that equals. Negative 4 times 3 divided by 4 squared plus 6 times negative 3 divided by 4. Oops. 3 divided by 4. And then we have minus 1. And so we get 1 1/4, which is going to be 5/4. And so that's our k. And so our vertex is equal to 3/4, 5/4. Okay, again, we don't need that, but this will then tell us what our max is, because we know it's a max. So our max is 5/4 at x equals 3/4. So that gives us this, and then we have our 5/4 here, which gives us that. So we have our domain and range. So domain and range, our max, our axis of symmetry. And so now what else do we need? Min, now we have x and y intercepts only. All right, so y-intercept, so we just have to plug in 0 for the t in this case. So h of 0 equals, well, that's 0, and that gives us a negative 1. And so our y-intercept is equal to 0, negative 1. So that was pretty easy. All right, so now what we need to do is we need to factor this if possible. Let's see. With that negative there, that makes it a little more difficult. So I can't factor that. So because I can't factor it, we have two other options. We have the non-factorable. We can convert it into the form a times x minus h quantity squared plus k, and then work it down, say 0 equals that, and solve for this one. Or we can plug it into our quadratic function. So what am I going to do? I'm going to do both to kind of show you which way you might end up thinking you want to do at this point. Because at this point, I can't see any way to factor that one. I don't see when you have a -4 and a -1 getting a 6 out of that. So that one I do not think is factorable. And so again, one way is to plug it into our new function as h of t equals -4 times x minus the h, which was 3/4 quantity squared plus 4k and or plus k, not 4k, plus 5/4. And so that gives me the function in the standard form. That was the general form. Now we have it in standard form. Now let's see if that's easier to solve. So what we're going to do is we're going to say 0 equals -4 times x minus 3/4 plus 5/4, and that's squared. Now I'm going to subtract 5/4 from both sides. And so -5/4 equals -4 times x minus 3/4 squared. Now I need to get rid of that. Well, if I divide by a negative and have a negative here, guess what happens there? That's going to become positive. So because of this, I'm not going to worry about dividing by the negative. And dividing by a 4 is the same thing as multiplying by 1/4, right? So if I multiply by 1/4, that's going to be the same thing. And I could have taken it times a -1/4, but I saw a negative on both sides, so I knew it was going to become positive. Now that's going to give me 5/16 equals x minus 3/4 squared. Okay. Now what do I have? Well, now I have something. I have a squared on one side and non-squared on the other side. And I need to get rid of the squared because I have to solve for that x. So what I'm going to do is let's write this in a different color. I don't know, green. Let's take plus or minus the square root of that. And this side, I'm just going to take a square root. And so now this becomes plus or minus square root of 5 over, and a square root of 16 is just 4. Okay, so we didn't have to worry about anything there. That was that. And then that's equal to x minus 3/4. Okay. Now I'm going to add 3/4 to both sides. So that's just going to give me, let's see where I'm going to do it, maybe here. So x is equal to, and then I have 3/4 plus or minus square root of 5 over 4. Okay. And so that's going to give me my 2 points. And so my x-intercepts are going to be, and I'll have 3/4 plus the square root of 5/4, comma 0, and I'll have 3/4 minus square root of 5/4, comma 0. Okay, so that's going to be my x-intercepts working it the second way, okay, because that was the second way, using the non-factorable, convert it to the standard form, and then set it equal to 0 and see if you can make it work. Okay, so it did work. We got answers. Okay. Now let's do it the other way. What's the other way again? Well, that's using our formula. The x equals a minus b plus or minus the square root of b squared minus 4ac all over 2a. Okay, now we're just plugging in things from our original equation. So what do we have? We have x equals minus b. B is 6, so it's a minus 6 plus or minus the square root of. Now we have b squared, so that's going to be b squared. 6 squared is 36 minus 4 times a, which is -4, and then times c, which is -1, all over, and then we have 2 times -4. Okay, so the only thing I did myself, this was, remember, 6 squared, but I just wrote it as 36, so I could save a little bit of time. Then that gives me x equals minus 6 plus or minus the square root of, well, we have 4 times 4 is 16, and those two negatives make a positive, but I have a negative here, so it's 36 minus 16, which is going to be 20. And then that's all over 2 times -4 is -8. Okay. Now, can we simplify? Sure we can. So that's going to be x equals, and then I'm going to simplify the radical because that gives me -6 plus or minus. That's, remember, square root of 4 times the square root of 5. Okay, 20 can be broken down into 4 times 5, and I can take the square root of 4, and that's going to be 2 square root of 5 all over -8. Okay. Now, what do we have? Okay, well, now let's come up here. X equals, and again, this is a long drawn out process no matter which way you do it, but we should come up to the same answers. Now I'm going to rewrite this as two fractions, kind of, because we had two fractions when we got done. So we have a -6 over a -8 plus or minus, and then we had 2 over square root of 5 over -8. Now it looks like we can cancel, so let's go back to red. Well, negative over negative is positive, and 2 will go in here 3, 2 will go in here 4. Now this, I change one of these, when I take a negative here, that becomes negative, and when I take a negative here, that becomes positive. So then that changed, so it's really negative positive, but you know, what does that mean? It still means plus or minus. It doesn't matter if the negative's on top or the positive. And now 2 will go in here once, 2 will go in here 4 times. So now I reduce this to x equals 3/4 plus or minus square root of 5 over 4. And when Viola, or voila, however you want to say it, you get back to the same thing. Okay. So again, one was quadratic formula, one we did standard form, and both of them we got the same x-intercepts, both of them. Okay. So I believe that's all we're supposed to get: axis to symmetry, max, y and x-intercepts, and the domain and range. Okay, so let's stop there, and I'll come back in a little bit.